Hello everyone. Today we will be looking at how the warming of the Gulf of Maine is affecting the local ecosystem. Why is this region important to look at? Well, the ocean temperatures here have been rising 3 times faster than the rest of the ocean. The graph here shows the warming rate of the Gulf of Maine in red and the global ocean in blue. And while both are rising, since the year 2000, the Gulf of Maine has been warming at a higher rate. There have also been reports of non-native species, and since this area contributes a lot of seafood, it has great economic importance. Surface currents have a large influence on temperatures in this location, and we'll take a look at some of the characteristics of them. Surface currents are driven by the winds. As wind blows across the surface of the water, friction drags water along with the winds, and this impacts about 10% of the ocean's water. They are also influenced by the Coriolis effect and the coastlines of continents. Let's take a deeper look into the features of surface currents. Firstly, the Coriolis effect acts upon the particles of water. This is an apparent force resulting from the Earth's rotation. Since the Earth is a sphere that rotates on its axis, different latitudes rotate at different speeds. This is what causes objects to appear to be deflected. And if you were standing on the equator facing north, objects in the northern hemisphere would be deflected to the right, and standing on the equator facing south, objects in the southern hemisphere would be deflected to the left. This is what causes particles to follow a curved path. The Coriolis effect contributes to geostrophic flow of water. The water in the ocean basins piles up in a hill, and both the Coriolis effect and gravity act upon it. Ideally, this would cause the water to move across the hill. However, friction causes the water to follow a downward flow across the hill of water. The result is the formation of gyres in the ocean basin. Gyres are large, circular moving loops of water. In the southern hemisphere, the gyres rotate in a counterclockwise direction, and in the northern hemisphere, the gyres rotate in a clockwise direction. The colors of the arrows indicate the water temperature. Water coming from the equator moves up the western boundary current of the gyre, making it a warm water current. As this water moves closer to the polar regions, the water cools and then is transported back towards the equator as a cold eastern boundary current. Now we can take a look at the North Atlantic subtropical gyre. We can see that the Gulf of Maine is influenced by the Gulf Stream, which is the warm water western boundary current, as well as the cold water Labrador current that enters the North Atlantic from the Arctic. As climate change melts the sea ice in the Arctic, the Labrador current is weakened, and the Gulf Stream becomes intensified. A simplified way to think of this would be like a faucet on a sink. With both the cold and hot water turned on, the water coming out of the faucet would be some intermediate temperature. This would be the temperature before the effects of climate change. Now, if you were to turn the cold water on the faucet down and the hot water up, the water coming out of the sink would become warmer than it was previously. This is what climate change is doing in the Gulf of Maine. We'll now take a look at how this change in temperature impacts the ecosystem. In the ocean, water is stratified, or separated into layers based on density, with warmer, less dense water at the top and colder, denser water at the bottom. When the temperatures between the surface and the deep water vary, a thermocline develops where a rapid change in temperature occurs. This thermocline prevents the water above from mixing with the water below. Since the Gulf of Maine is located in the mid-latitudes, the presence of the thermocline varies each season, and this affects the growth of phytoplankton populations. Phytoplankton are the primary producers in the ecosystem, meaning that they convert solar energy into organic carbon, supplying the rest of the food web with energy. In the winter, the water becomes isothermal, meaning there is no thermocline, and that allows the nutrient-rich deep waters to mix with the surface waters. In the spring, the increase in sunlight and the presence of nutrients from winter mixing cause a bloom in phytoplankton production. In the summer, sunlight and warm water are abundant, but nutrient levels are decreased due to the consumption from phytoplankton and the thermocline that prevents mixing. During the fall, the thermocline weakens and allows the nutrient-rich deep water to mix with the surface again. Sometimes this results in a fall bloom, but it also fuels the nutrients for the next spring bloom in the fall and winter. Data has shown that in each season, the temperature trend has shown an increase in temperature anomalies. If the temperature increases so much in the winter and fall that the thermocline remains present year-round, the ecosystem will not have enough nutrients provided by the mixing of the deep water with the surface water to support the population. A NASA study has already shown a 65% decrease in the amount of phytoplankton productivity in the Gulf of Maine. This means that the amount of available energy for the entire ecosystem decreases. The changing temperature also causes species that are mobile to migrate north to find temperatures within their ecological niche. Based on the temperature trend, we can see how these changes are projected to impact some important species in the Gulf of Maine. In these images, habitat suitability is rated from 0 to 1, with 0 being not suitable and 1 being the most suitable. And we have the current habitat suitability with the projected suitability in the year 2060. For the American lobster, there was a large decrease in suitable habitat in 2060, with most of the habitable area in the northernmost part of the Gulf. For the Atlantic cod, there was projected to be no areas of high suitability, with only small areas in the north of the Gulf with intermediate suitability and many areas of low suitability. Lastly, for the Atlantic herring that is already struggling in this environment, there will be even less suitable habitat in 2060. So how can we act to slow the impact of climate change? Well, here are some options that you can take personally to reduce carbon emissions, as well as some actions that can be taken on a community and national scale. Until we can reduce the amount of emissions we put into the atmosphere, the effects of climate change will continue to threaten vital ecosystems like the Gulf of Maine. Thank you for watching. I hope this presentation helped you understand how we can change our behavior to help protect these vital marine ecosystems.